Greetings everyone, we will continue our discussion on information retrieval systems. In the previous session, we have discussed about pair trees and pair arrays. In this session, we will be going for the next part of your information retrieval systems, that is about stemming algorithms. So initially, we will be looking about the syllabus part, what are the contents which will be part of your stemming algorithms. Then we will be looking about the introduction to stemming algorithms, what are the various type of stemming algorithms we are having, and how we are going to measure the performance of a stemming algorithm. First, coming to this part, initially we will be looking at the introduction to stemming algorithms, that is how we are going to have what is stemming and what are the stemming algorithms we are going to have and what are the various types of stemming algorithms. Then we will look at the experiment evaluation of stemming to implement the compression of your inverted files. So we will be looking at all these topics as a part of this stemming algorithms. So first, what is stemming algorithms? Stemming algorithms are programs that relates to morphologically similar indexing and searching terms. So whenever you are having similar terms in your particular information retrieval systems, we can perform this part called as stemming. We already looked about this part in the initial stages about while constructing your information retrieval systems. So whenever you are having similar terms like this, we can create one stem word. That part will be calling it as stemming. So this stemming algorithm, this stemming part will be implementing by using your programs. Okay, where we should be having morphologically similar terms. Okay. We should be having morphologically similar terms, that is morphologically means when you break down that particular term, it should be similar like thing. Okay, so whenever you are having these particular words like consult, consultant, consulting, consultative, consultants, consulting, okay, these all parts can be broken down into a single word called as a stem, called as a consultant. Okay, so that is how you can create one stem for a large set of values. Okay. So this particular thing can be done. So stemming is used to improve retrieval effectiveness and to reduce the size of your indexing files. Instead of storing each and everything present in your non-stemmed words, that is, instead of indexing all these terms, we can index only a single term. Okay, so this will result in reducing the size of your index first. Whenever you are storing your particular stem words, it will help you to reduce the size of your index. Apart from that one, you can get the retrieval effectiveness. Okay, instead of searching these many words, you can search for a single word. Whenever I search for these particular words, I can get the result of all these particular stem related words. Okay, it will provide you better retrieval effectiveness, and also it will reduce the size of your index present for your information retrieval system. So this is about stemming, where you will be having algorithms which creates the stem, and it will help you to reduce the size of your index, and it will help you in improving your retrieval effectiveness. So our technique, one technique to improve your information retrieval system performance is provide searches with ways of finding morphological variants of search terms. So to improve your information retrieval system performance, we can provide ways in which you can search for related words. Not only a perfect word, not only a specific word, we can search for related words. So this will improve your information retrieval performance. If for example a searcher can enter the word stemming as a part of the query, it is likely that he or she will also be interested in such variants like stemmed stem. Okay, so if your query is related stemming, okay, he might be also interested in related words like stemmed stem. Okay, so whenever I am searching for some word called as consulting, okay, as a user you might be interested in other words like consultant, consultant, consultative, consultants, consulting. So you might be interested in all these words. Okay, you might be giving query in a single word, but as an information retrieval system will be storing only a single word. So this particular word will give all these results. Okay, this particular word, whenever you search for this particular thing, you will be getting the result of all the related words. These related words will provide better search effectiveness. So as a user, if I try to search for a single word, if I get the results of all the related words, then I will be better positioned to judge the results. Okay. So this is where you will be implementing your stemming process to get your to get your information retrieval performance effectiveness and your search effectiveness. So to improve the information retrieval performance as well as to get effective search results, we will be using your stemming process. Stemming is used in information retrieval to reduce the size of your index files. That is the first thing. So in order to improve your performance of your index, you should be having index which is very small, okay, and it is indexing large number of items. So if your particular thing is able to reduce the size of your index, if your stemming algorithm is able to reduce the size of index, it will indirectly improve the performance of your information retrieval system. Your stemming algorithms will help you to reduce the size of your index. A single stem could typically corresponds to several full terms. By storing stems instead of terms, okay, we will be storing the stems instead of the complete full terms. Compression factors of over 50% can be achieved by performing this thing. Okay, we will be having terms in this manner. Instead of storing all the terms in your index, we will be storing only the stem. This is the stem of all these words. So we will be storing only the stem part. When I store the stem part, we will be able to reduce a large part of the index. So as you can imagine, instead of storing your terms, you will be storing the stems. So you can compress your particular index by more than 50%. So as you can understand, the size of the index will help you in information retrieval performance. And terms can be stemmed at indexing time or at the search time. Okay, these terms can be they can be stemmed both during the indexing time, that is while creating the index, or during the search time as well. You have seen this in the first initial stages of your information retrieval system functions. So I will show you where you have seen this one. So this is where you will be constructing your information retrieval system. You have seen this in the initial part of your course, where you can perform the stemming process during the creation of your index. So during the creation of your index, what you are going to do, apart from the words which are deleted from the stop list, the remaining non-stop words have to be stemmed here. Okay, whatever may be the remaining words which are apart from your stop list, the remaining words have to be stemmed. Those stemmed words only will be moved into your database. Okay, so the stemming will be performed at the indexing side, that is while creating your index, and the stemming also will be performed during the query side, that is whenever the user is providing the query. Okay, when the user is providing the query, you are going to perform the stemming as well. Instead of searching for a more specific term, you can search for a more generalized term. Okay, instead of searching for the query, whatever the query which you are getting, instead of searching for a large term, we can search for one stemmed term. Okay, we can search for one stem. So with this we will be getting a better result. Because we will be getting large number of we will be able to create large number of stems. These stems will reduce the size of your index initially, and they also will be helpful for getting you better results while retrieving documents from your information retrieval system. Okay, so this is what you have to know about regarding stemming process. You will be having initial word list, the keyword list. From those keyword lists, you have to be performing stemming. Okay, when you perform the stem, the number of keywords which are needed to be indexed will be reduced by more than half. Okay, these are called as stemmed words. These stemmed words only will be usually placed in your databases or your information retrieval system. And whenever you are providing the query also will be stemmed to match your results in the database. Okay, so and you will be getting more relevant documents, not the specific documents. You will be getting the relevant documents. Why? Because you might be searching for only a specific word, but apart from the specific keyword, you will be getting all the related keywords which are created for the stem. Okay, so that is how this particular information retrieval system will work by using the stemming process. The word conflation. So conflation meaning the act of fusing or combining as the general term for the process of matching morphological term variants. Okay, usually this stemming word is otherwise called as conflation. Stemming is otherwise called as conflation, which is the act of fusing or combining the as a general term for the process of matching morphologically term variants. Whenever you are having related terms, we can combine them and form one single term. The term will be calling it as the stem. That is why we will be calling it as stemming here. The other word for stemming will be calling it as conflation. Conflation can be either manual, whatever you are doing here, that is the stemming part or the conflation part. It can be done either manually or it can be done by automatically using programs. So by manually we can use the regular expressions to perform the completion, or automatically by various programs called as stemmers. So the programs which implement your stemming will be calling it as stemmers. There are 4 automatic approaches. We will not be covering your manual approaches here. We will be covering only the automatic approaches. There are 4 automatic approaches. So the conflation methods are 2 types. One is your manual and another one is automatic. So the automatic programs will be calling them as stemmers. So we are having 4 different types. One is your affix removal method. The affix removal method can be done by longest match or simple removal, or your automatic stemmer. Another automatic stemmer is the successor variety, and you are having another table lookup and n-gram. So we'll be looking about all these different types of your automatic stemmers in the further sessions. For the time being, know that these are the various stemming algorithms you are having as a part of information retrieval system. So the successor variety, whatever you are having as a part of the taxonomy, successor variety stemmers use frequencies of the letter sequences in a body of the text as the basis for stemming. Okay, so it is going to use the frequency of letter sequences in the body. Okay, how many times a particular sequence of letters is repeated in the text. That particular thing will be used in your successor variety. And the n-gram method, okay, will perform your stemming by using the number of digrams or n-grams they share. Okay, based upon the number of n-grams or digrams they share, they will be performing your conflation. And terms and their corresponding stems also can be stored in a table. Okay, you will be having the terms. Along with the terms, we can store the stems in a table. So by storing both the terms and the stems, we can perform table lookup operations. That is, stemming is then done by using lookups in your tables. Okay, so this table lookup operations also can be done. So this is another type of your stemming algorithm. So these are the various types. That is, you will be having the successor variety where you are going to use the frequency of successors. Then you are having table lookups where you are going to store your complete stems and terms in a table and perform the lookups, and you are having n-gram where you will be using the diagrams or n-grams to find out the stemming process. So we will be looking about those stemming process in the later sessions. For the time being, this is about the taxonomy or the various types of your stemming algorithms. And to evaluate the performance of your stemming algorithm, we are going to use various criteria. So various criteria for judging your stemmers. One is correctness and retrieval effectiveness and compression performance. Correctness means how much better you are performing the stemming. Okay, whether you are performing optimal stemming or whether you are performing suboptimal stemming. that will be your correctness. Okay. The second is the retrieval effectiveness, how many number of your retrievals are getting from your information retrieval system, that will be your retrieval effectiveness. Compression performance, how much of your original index is getting compressed by using your stemming algorithms, that will be your compression performance. We'll be looking about these things, issues regarding these things. So regarding to the correctiveness of your information retrieval system, there are two ways stemming can be incorrect. Okay, this will be regarding your correctness. So there are two ways your stemming can be incorrect. One is over stemming, another one is under stemming. Okay, by the words you can understand over stemming and under stemming. When a term is over stemmed, too much of it is removed. If you take one term and if you perform too much of your stemming on these words, then the word will be removed. Too much of the word will be removed. For example, if you are taking consulting, okay, if you perform too much of stemming, you can remove most of the word and you can only place CONS. Okay, CONS. That will be over stemming, where you are removing too much of the word. Okay, that will be calling it as over stemming. Over stemming can cause unrelated terms to be conflated. Okay, so when you are performing over stemming, too many number of unrelated terms will be stemmed to one stem. Okay, if you perform optimal stemming, then only related terms will be moved to one stem. But if you are performing over stemming, unrelated words also will come to one stem. Okay, now too many words with starting with CONS will come into this consult. Okay, will come to one stem. So you should not be performing over stemming. Next, the effect of your information retrieval system because of your over stemming is retrieval of non-relevant documents. So when you perform over stemming, what will happen? So when I search for this particular word consulting, then all the related words regarding CONS will come as your retrieval results. So when you perform over stemming, the retrieval documents will not be related documents. You will be getting too many unrelated documents. That's regarding over stemming. When you come for under stemming, so under stemming is the removal of too little of a term. Okay, so if I having the consulting, okay, so if I remove only two letters, now I am having CONSULTI. This is the word I am stemming. Okay, so this is under stemming, where you are not stemming properly or you are removing too little of your word. At that time, what will happen? Under stemming will prevent related terms from being conflated. So now if I stem this word only to the two letters, then it cannot be stemmed into this word, consult. Okay, why? Because this is unrelated word and consult is unrelated word. So under stemming will prevent, even though it is a related word, the related word from being conflated. So they will not be dropped to one stem. So too many related words also will not make one stem. So the effect of understemming on information retrieval performance is that relevant documents will not be retrieved. Okay, when you are performing understemming, even though you are having relevant documents, you will not be getting them as result. So these are the relation with correctness, where you can be performing understemming or you can be performing overstemming. So you should be taking care of your performance in such a way that you will be getting optimal stemming process. Okay, so this is about your correctness of a stemming algorithm. The second thing is stemmers can also be judged based on your retrieval effectiveness, how effectively you are retrieving your documents. Usually this is measured with recall and precision. Okay, usually whatever you are getting the results, it will be measured by using recall and precision. We have already discussed what is recall and precision in the first unit. Precision will be how many number of correct documents you are retrieving, and recall means how many perfect documents you are getting from your system. Okay, so that is maybe about information retrieval. Apart from that one, based upon their speed, size, also you can check your stemming algorithm. Okay, what is the size of your index? What will be the speed of your information retrieval? Okay, all these things will come for your stemming algorithm performance evaluation. Finally, they can also be rated upon their compression performance. Okay, your stemming algorithms can also be rated by using your compression performance. If I perform this particular stemming algorithm, how much of my original index is compressed? Okay, whether it is giving 50% compression or 60% compression. All these things will be related to your stemming algorithm. So the stemming algorithm performance will be evaluated by these three parameters. One is the correctness, so how much perfectly you have done your stemming, whether you have understemmed or overstemmed. Next, it will be evaluated by your retrieval effectiveness, how fast you are delivering the result and how correctly you are delivering the result, by their speed, what is the size of your index, and by the compression nature of your stemming, how much compression you have done. That will be about your stemming algorithm performance. So in the next session we will be looking about how this particular stemming process will be done and what are the various algorithms, all the discussion of the all algorithms, whatever you are having, the stemming algorithms you are having, we'll be looking about all the details of those stemming algorithms. Thank you.